Okay, so the objective of this lesson is to be able to form algebraic expressions from the information that we're given. So let's look at a few examples. Okay, so here's the first one. We've got a cuboid here, a solid cuboid, and we're told it has height p, length q, width r, and the question is asking us to write an expression for the volume of the cuboid. Okay, so we have to look at what we know about volume. We already know the general expression for volume. Volume is length times width times the height when we're talking about a cuboid. So what we have to do in this case is to actually substitute in the length, width and the height in this case into our general expression, our general equation. We don't actually know the numerical values of the length, width and height, but that doesn't matter. We can still put what we do know in there. So in this case, the length we can take as being q. Instead of length, I'm just going to write q. I don't know how big q is, but I'm just going to write q. The width is r. So that's how far back the cuboid goes, and the height is p. So I'm going to write it down as q times r times p. Of course, in algebra, we don't have to put the times signs in, so we don't get them confused with x's. And also, we don't have to, but it's convention to put the letters in alphabetical order. So I'm going to rewrite that as p, q, r. So that's my expression for the volume. Okay, let's go on to another one. Okay. So we've got the same cuboid again, height p, length q, width r. This time we're being asked for an expression for the surface area A, but only of the front fully shaded face. So it's only this face here. Now we know that area is length times width. So in this specific case, let's look at the length and the width of the fully shaded face. So in that shaded face there, the length of it is q times by the width of it. I mean, although it's actually going upwards, that's the width of that flat face there. So the width is p. Q times p. But again, I'm going to rewrite that without the multiplication sign in there because I don't need that, and I'm also going to put it in alphabetical order. So I'm going to rewrite it as the area is pq. Okay, on to third example. So a little bit trickier, the third example here. This time we're being asked for an expression for the total surface area S of the whole cuboid. A little bit trickier question, but we'll just work through methodically and we can get it. So, surface area S, so the whole cuboid. Surface area, remember, is the outside area, a measure of how much surface there is to it. So actually, we need to think how many faces are we actually adding up here. So if we look at that cuboid, imagine it, we've got the ones we can see, we've got the front face, a top face, a side face. We've also got the other side face, the bottom face which we can't see, and the back, the face on the back of it. So we need to add all of those up. So that's 6 altogether. So for S, we're looking at the area of, we've got the front we're going to look at. So it'll be the area of the front face. We're also going to add on the area of the back face. That's 2 of them. Then we're going to look at the left-hand face. And also we're going to add on the area of the right-hand face. And then the 2 that we haven't included the top yet. And the last one is the bottom face. So whenever you're doing a question like this, make sure you're adding up all the faces. So I've got 1, 2, 3, 4, 5, I've got 6 faces. So for each of those now, looking at the measurements that we're given, let's work out the area of each one. So the front face there, we've just done that before. We did it in the last part of the question. That's P times Q. So that one was PQ. If the front is PQ and it's a cuboid, the back face must be the same. Front and back are identical. So that's another PQ. Then we'll look at the left-hand face. Now we can't see the left-hand face there, but we know it's going to be the same as the right-hand face. So the area of that right-hand face will be how tall it is, P, times the width of it there, R. So the left-hand face will be PR. And the right-hand face, we just said, was exactly the same area as well. So that one will have an area PR, which is P times R. Okay, on to the next one, the top face. So we can see the top face on the diagram there. Again, it's the length times the width of the top face. So that's going to be Q, because that distance across there is Q, times the width of it, which is r. Top face has area QR, the bottom face must be the same. They're identical areas because it's a cuboid. So that's another QR. Okay, so we've got that expression now, but we can simplify that as well. So here we've got PQ plus PQ. Much easier to put that down as 2PQ. So there's two of them. We've also got PR plus PR. So we can collect those together, collect the like terms together, and call that 2PR. And then we've also got QR plus QR, which is 2 QRs. So there's my expression for the surface area of the whole cuboid. Okay, so that's it. Now it's your turn. So have a go. You've got 4 questions to have a go at there. Excuse me. Work your way through those. You'll need to pause the video while you're working through those, and then you can check your answers afterwards.